All right, so now we're going to talk about how do we interpret a p-value in context. So this p-value, p stands for probability, is the probability of getting evidence for the alternative hypothesis as strong as or stronger than the observed evidence when the null hypothesis is true. Okay, so it's the probability of giving evidence for the alternative when the null is true. And you're going to see that that all comes into play when we interpret the p-value in our next example. Okay, so keep that all in mind. All right, so example 2, do teens get enough calcium? Calcium is a vital nutrient for healthy bones and teeth. The National Institutes of Health recommend a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers aren't getting enough calcium on average. Is this true? Researchers decided to perform a test of. So let's talk about these hypotheses, right? So we have the null and the alternative. This is a means question, right? Again, it's not a percentage, so it's not a proportion, it's a mean. This is your null value. So your null mean value is 1,300 milligrams. And again, they are concerned that they're not getting enough. They're concerned that their daily intake is less than 1,300. So that's why it's a one-sided. Okay. So they're going to do this test where mu is the true mean daily calcium intake and the population of teens. So there's your definition of your parameter. They ask a random sample of 20 teens to record their food and drink consumption for one day. The researchers then compute the calcium intake for each student. Data analysis reveals that X bar is this. So you can see that the sample mean is actually less than 1,300 with a standard deviation of this. Researchers perform a significance test, which we'll do in the next couple sections, and obtain a p-value of 0.1405. Interpret that p-value. So the first thing we do is we talk about the null value being true, assuming that the true mean daily calcium, I looked away and I spelled it wrong, daily calcium intake in the population of teenagers, and I'm just using right here where it defined it, assuming that the true mean daily calcium intake of in the population of teenagers is 1,300 milligrams. So again, that's just me stating the alternative. That's what I'm doing here. I'm stating the null. That's me stating the null. Sorry about that, misspoke. That's me stating the null. Assuming that the null is true, there is about a 0.1405. And again, for some reason, they just use the decimal. They don't use the percentage. I don't know. I'm just going to follow them. There's a 0.1405 probability of getting a sample mean of 1198 milligrams or less. And again, the or less comes from the inequality symbol, or less, by chance alone in a random sample of 20 teens. Assuming that the true mean daily calcium intake in the population of teenagers is 1,300 milligrams, there is about a 0.1405 probability of getting a sample mean of 1198 milligrams or less by chance alone in a random sample of 20 teens. So again, we are identifying how often by chance alone we would get this sample mean value. Okay. So there you go. And again, we have to think about, moving forward, what do we compare that p-value to, right? In the past, it's been a lot of 5%. So we'll see what we do in the future. Okay. All right. So that's objective 2. One more objective coming.